All right, it's 10 o'clock, everybody. Good morning. My name is Jeff McBride. I'm one of the variable refrigerant product specialists here at Long, and will be your host today. We appreciate you attending this latest edition of the Long Coffee Break. Today's topic is electrification, decentralized ventilation, and 100% outside air for energy and efficient and healthy buildings. And with that, it is my pleasure to introduce James Dean with Oxygen 8 to lead us off in this discussion. James?
Great, thanks Jeff for the kind introduction, and to the Long team for inviting us to introduce Oxygen 8. As Jeff mentioned, my name's James Dean. I'm the CEO and founder of Oxygen 8. I'm a clean tech entrepreneur. My previous company you may have heard of was called D-Point. It became Core. We invented a membrane that's used in many of the enthalpy exchangers, including the Daikin Vision and Daikin Rebel air handling units. Also would like to introduce my colleague, Erdem. Erdem is application engineering manager at Oxygen 8 and has a lot of experience in integrating VRF systems with dedicated outside air systems. So Oxygen 8, we develop DOAS and ERV systems. We saw an opportunity in the market with, as Jeff mentioned, electrification, decentralized ventilation, and 100% outside air to create a low-profile air handling unit that integrated with VRV, a fully packaged solution that integrates energy recovery, MERV 13 filtration, heating, cooling, dehumidification, humidification, and controls all in one packaged unit. So I'm sure most of you have sat through lots of presentations over the last year with COVID, and all the different technologies, ventilation, filtration, purification, ionization, UV lights. We're not going to talk about COVID today, but we believe that, post-COVID, ventilation and indoor air quality is going to become as important. A really interesting study that was published by the Harvard T.H. Chan showing that cognitive function and test scores improve significantly with lower CO2 levels and lower VOC levels. So we see this going to be the next generation for ventilation and 100% outside air. ASHRAE 62, as many of you know, prescribes minimum ventilation rates. And really, the key word there is minimum. If you look at a typical school, you'd be between 400 and 500 CFM, which is about 3 air changes per hour. If you look at the scientific data, it shows really we should be in that 5 to 6 air changes per hour. The main reason why I would say we haven't had higher air change rates and dedicated outside air systems in the past is the energy penalty that's associated with that, particularly in cold, dry climate zones and hot, humid. The big breakthrough that we've seen in the last couple of years is in heat exchanger technology. Traditionally, it was the cross-flow cores that you see on the left there, where you would get between 50 and 70% sensible recovery effectiveness. In the last couple of years out of Europe, we've seen these high-efficiency counterflow cores where you get 70 to 80%. And the latest technology that Erdem will show in some of our product lines has the cellular structure where you can get 80 to 90% sensible recovery effectiveness. So now you can have 100% outside air with very small energy penalty. The other key trend we're seeing in the West Coast, northeast of the United States and Canada, and happy to also see in Denver, is the electrification of buildings. Some call this decarbonization, and a move towards all electric HVAC solutions. And the big growth that we're seeing is in heat pump technology. So at Oxygen 8, we've partnered up with Daikin, who we see as the leader in VRV technology. Here we integrate the Daikin outside condensing units by packaging DX coils inside our units with electronic expansion valves and the Daikin controller to provide that supplemental cooling or heating to provide 100% air at neutral air temperature. The other key trend we're seeing is decentralized ventilation. This has been very common in Europe, Asia, and the Middle East over the last decade, and we're seeing it now come to North America. From a developer's perspective, the big advantage is getting the HVAC equipment off the roof, which is some of the most valuable real estate. In the bottom right-hand corner there, you can see your typical rooftop mechanical room, where these developers would rather have green space, beautiful rooftop terraces or solar panels up there. Also reducing the roof load by not having equipment up there. But there are many other advantages to decentralized ventilation: better air quality by being able to better zone, better redundancy by having not just one air handling equipment serving the whole building, less need for smoke and fire dampers, and lower fan energy by having smaller and shorter duct runs. So I'm going to introduce you our first product that we launched 2 years ago called Nova. This is a low profile indoor ERV, and when we integrate it with VRV, we call it a DOAS. You can see it's quite slim profile, ranging from 16 inches to 30 inches, and the range of flow from 775 CFM up to 35 CFM, and it comes in 5 different sizes. We've designed this to meet the ASHRAE 90.1 requirements of 50% total recovery. In most parts of the United States, we're seeing engineers just wanting to meet that minimum ASHRAE requirement. A look inside Nova, to the right there, you see our energy recovery section. So we have a cross-flow core, MERV 13 filters on the outside air side, MERV 8 filters on the return air. We're using high efficiency, low specific fan power fans, ECM fans in this section here. Double walled casing, and Erdem will talk about our fully integrated controls that we have as well. Coming included are all the sensors, temperature, pressure, RH sensors, and it can include CO2 sensors as well. There is an option for bypass in the Nova product line, as well as our Ventum product line that Erdem will talk about. This just shows how we integrate VRV. So we purchased the DX coils from Modine. We get the electronics expansion valve kits from Daikin and the controller, and we package it all inside our casing. And then again, that's connected to the outside condensing unit. So I'm now going to pass it over to Erdem, who's going to talk about our high efficiency products, Ventum, and the counterflow cores that are used in it. Erdem?
Thanks, James. So we're going to be launching Ventum product line this summer, which has high efficient counterflow heat exchangers. The airflow rate range is pretty much similar to Nova, from 400 CFM all the way up to 3000 CFM. It's going to be installed in the ceiling plenum horizontally. The sensible only heat recovery can go above 80% sensible recovery effectiveness, and the ERV version can go above 75% sensible and above 65% latent recovery. As you can see, there are 3 different physical sizes, and the height of the depth of the unit is changing from 18 inches to 34 inches. So because Denver is a hot and a dry climate, I wanted to show you guys the performance of both ERV and HRV. And if you look at the parameters, I assume the typical design conditions for Denver and typical return air conditions. This exercise is done with the 600 CFM unit. So if you look at the performance of the ERV, in summertime, the living air temperature is around 79 and 61 degrees. And in wintertime, it's 55 and 44 degrees. And if you look at the effectiveness, sensible effectiveness is around 79%, and the latent effectiveness is 68, 69%. Now, if you look at the performance of the sensible only recovery device under same conditions, same CFM, the summer living conditions is pretty much close to the ERV, 78 degrees with 54 web pulp. But we see the huge difference in the winter living air performance from 55 to 62 degrees. But of course, since the sensible energy recovery doesn't recover humidity, it's a dry air. So the sensible effectiveness of this unit is 85%. So based on the application, we can look at which one to utilize, either HRV or ERV, depending on how many people in the space and what's the best application to fit. So as Nova unit line, the Ventum is the same. It comes with integrated factory-mounted controls. There are some benefits to that. First of all, if we have a small building with no building management system, by bringing Ethernet cable to the unit, the unit can be connected to building network and can be controlled via any device that is in the same network. If, let's say, we have a large building with a building management system, then the controller is BACnet IP and it's BTL certified. There are 70 plus control algorithms in this controller. I'm going to talk about some of the multiple airflow control options. James already mentioned the discharge air temperature control, either via hydronic valves or DX expansion valves. You can assign weekly programs. We measure the filter pressure drop across the filters. So if the filters get dirty, it sends an alarm to the building management system. And if there are any fire alarm strategies in the building, the unit can adapt easily. So let's talk a bit about the demand control ventilation. I think in the post-COVID world, it's going to be a very hot topic because bringing outdoor air is expensive. So if we have a single zone, my recommendation is to use a CO2 sensor in the return air duct and assign minimum and maximum airflow rates to the unit. And based on the CO2 sensor readings, unit will modulate its speed to maintain the right amount of ventilation air to the single zone. Things get a bit more complicated when we have a multiple zone application. In this example, you see 3 different zones. Each zone has supply and return VAV damper, preferably pressure independent. And the supply damper is controlled via local CO2 sensors, changing the damper position based on the CO2 readings. And if you utilize the pressure transducer in the ductwork, then the unit will sense the pressure change and ramp the speed up or down to provide a necessary amount of ventilation to each zone. Now I'm going to be talking about the residential product line that we're going to offer very soon. The first product is Salda. It's a company that we have partnered up with from Europe, Lithuania. They have Passival certified HRVs, can go up to 85% sensible recovery effectiveness. On the right side, you see the Vita HRV. It is pretty much close to Salda unit. It's coming close to Passival's performance, but it's not Passival certified. So this product aims projects that are aiming Passival's criteria, but not want to pay the Passival's premiums. And in the middle, you see the ERV integrated with Daikin's FXTQ air handling unit, which can be connected to air-cooled or water-cooled condensing units. And the ERV is sitting on top of that air handling unit. And down below, you see the plenum. So the supply air of the ERV is down below and feeding the plenum underneath. And the FXTQ is heating and cooling the air, and the ERV on top provides the ventilation air to the space in this slim and combined application. And as some of the projects that we've done so far, University of British Columbia, so as you can see on the left picture, they have a sloped roof, so they couldn't put the ventilation units up in the roof. Therefore, they convert one dorm room into a mechanical space where we provided 4 oxygenate units, providing 8,100 CFM of outside air, combined with the DX coils, have the supply air temperature control. And the other project we've done in Boston, it's an office retrofit project. It's an old building. They have a ceiling space. Therefore, we were able to provide 2,700 CFM of fresh air in connection with a Daikin 5-ton VRVS outdoor unit and have supply air temperature control. And the last project I want to show you is a restaurant retrofit from New York City. The owner wanted to put the unit just entrance of the unit, the restaurant, and hide the unit behind the nice looking barrels, as you can see on the left picture. So with this unit, there is a DX cooling and a post-electric heater, and it's not just controlling the leaving air temperature, but also controlling the leaving air humidity levels.
Great, thanks, Erdem. So that's it for our presentation. If anybody has any questions or wants some selections, please reach out to your local Long sales representative or Erdem or myself. Also, I want to point you to our website, www.oxygen8.ca, where we've got some great technical information, and then also to follow us on LinkedIn. Thanks again to the Long team, and look forward to working together with you.
Hey, thanks very much, James and Erdem. I did notice that there was a question that came in on economizers. We don't have time to answer the questions today, but I'll jot it down and we'll run that by James or Erdem and get back to the person that asked that question. Next week's topic for the Long coffee break is Mars Air Curtains, Solving Space and Energy Loss Challenges, hosted by Chris Burke. Hope you all enjoy the rest of your Thursday, and we really appreciate you guys taking the 15 minutes to attend today. Thanks, everybody.